Okay, so tree graphs still. This is lesson 34 now. With the tree graphs, we need to know what the transformations are. Is it still a possibility that I can ask you to just draw the normal mother graph of sin?
Yes.
Yes, in an exam. Even in a trig end exam. It's not impossible. A little unlikely because they usually want to see some sort of a transformation, but it's not impossible. So if I ask you to draw it, we did draw it yesterday. We have to go and look at what the transformation is about. Remember the boys and girls? Is this a boy or a girl transformation? A girl because it's got to do with the x. X is the girls, y are the boys. So x over 2 says I take the angle and divide it by 2, but that's not what I'm going to do. I'm going to take the x and time it with 2. If I go back to my sin mother graph, and I want to then apply it to this graph, then I just take the 1, 2, 3, 4, 5 points, and I do exactly what I said over here, time every x with 2. So the first point, the x was 0, times with 2, so it's 0, so that was my first point. My second point was at 90 and 1. It's going to stay 1, but the 90 is going to become what? 80. So this graph is stretching. That's my second point, which used to be here. So it's now at 90. The next one was off the chart, because it was at 180, and that's now going to be at 360, which I'm not allowed to sketch here. So it should have been over here, around about. And that's why my graph goes down. And then we spoke about, usually then the question will say, show all points of concern, in other words, turning points, or the y-intercepts, x-intercepts, and if it hangs here in the middle of nowhere where you stop, then I need to see those endpoints as well. Now that's not a difficult question. You just have to go and substitute 270 in this new formula, which is 270 divided by 2. And when I do that on a calculator, it gets to 0,7. So 207, 0,7 is the coordinate pair then for the orange graph of F. Also to the left, because I started here, I needed to go down. And if the next one should have been at negative 90, and I timed it with 2, it should be at negative 180, which is again off the chart. So I'm going to 180 right here at the bottom, but it's going down, stopping somewhere in the middle of nowhere again. Substitute the minus 90 in there, and your answer came to negative 0,7. And it can't do strange things. You did something wrong on your calculator, now all of a sudden it's here. Then you should know, but some block can't go back up again and make things like that, bouncy stuff. It doesn't happen, all right? You should know that. For the cast graph, what happened? Every x
Minus 45.
is minus with 45. This says your graph must go to the left. What's standing there is x plus 45, but what you do with your mother graph of cos is you move each and every one of the 1, 2, 3, 4, 5 points you know out of your head 45 degrees to the left. So that one is not going to be at 0, it's going to be at negative 45. The next one won't be at 90, it will be at 45. The next one won't be at 180, it will be at 135. Also still at negative 1. Then 270 are now going to be at 225. And the next one at 360 should have been at 315, but it's also off the chart here. Going over there, but I've got to stop. And then we checked it out yesterday and we filled in there 270 in the place of x. So this came to 315. And we worked it out, it was exactly 0,7. So that means it's not just accidental, it's definitely the same point, which is going to help me now with my questions that's going to get asked. So in general, in a question paper, and go look at your exam aid. In the exam aid, you need to go work through these questions. There will be one of them, a variation on them. But you won't get 10 questions like this. I'll maybe ask the amplitude and where they equal and something else. 3, maybe 4 questions, never 10 like this. Just to make it easy for us, we just copied the same thing all the time. You've got to realize this won't always all be there. So for amplitude then, both of them do have an amplitude, right? It's only which one that doesn't have an amplitude. 10. So for F, it was 1, F which is the orange one, and for G, which is the yellow one, it also is 1. Then, what is the period of both of them? Remember in grade 10, we didn't do any horizontal shifts or stretches. So in grade 10, if I ask you what's the period for sin, it was 360. For Quasi it was 360. For Tane it was 180. And that was always the case. But now this year, since we're going to be doing something, it doesn't always have to be. If I don't do anything with the X's, with the girls, then it will still stay those basic answers for period. But for F, which is the orange graph, what happened to the X's? It's times by 2. So I taught you then your usual period of 360 is also
times by 2.
So that will give you 720. Did you get that right?
Yes.
Excellent. For G, what happened to your X's?
You minus by 45.
So is your period going to be minus with 45?
Yes.
No, guys. What does the minus 45 mean? It's shifted. So it doesn't do this, stretch and shrink. You just pick it up and it moves to the left or it moves to the right as is. But the movement doesn't change your
Graph.
period. Right, now for the domain and the range. Usually, domain is a silly question, but they can ask it. Domain of F. But guys, domain for any of these graphs go on until infinity, right? But there is one strange thing, and that's the tan graph. So basically what I'm asking for a tan graph, which isn't here, is if I ask for where you sketched it, it won't always just be that. You'll have to exclude all the asymptotes because it doesn't exist there. So that is not part of the domain of it, the x values. Remember the difference between domain and range. The x's and the y's. Now, for this case, both of them, the range, the domain, is between minus 90 and 270. You're all clear on the two different techniques of writing that. Either in interval notation, and then let's do the next one in normal notation. The range of G, and G was the cos graph, the yellow graph. The range of it goes from -1 up to +1. And please don't write the 1 on the left side and the -1 on the right side. You have to have the lesser one on the left, the bigger one on the right, with smaller than signs like you were taught always to do it in between. And then both of them are included. There's no reason like asymptotes and funny stuff that has to exclude them. And that's it. Minimum and maximum. Are you getting the feeling I'm asking some of the stuff twice?
Yes.
And that won't happen in exam. This is for exercise. Minimum value of F. F is your orange graph. Minimum value. Are we going to say -1 or just stop at -0.7? Since I'm only working here, you want to feel that that's the minimum value. But the question is, in general, what's the period? Even if I ask the period here, did you actually go 720? No, but you still said that the period was 720. You didn't go there, but the minimum value was negative. What are you with me? Because you might have thought to say -0.7. But the minimum value is actually -1 if you had continued up to infinity. Maximum value of G is 1. I prefer you writing it out than writing that. Because sometimes those little ones get missing in the marking process, especially in matric. Then the questions on estimate your answers. For now, you won't be able to work it out, but you're going to be soon. If I ask you where they cut each other, you can actually put equations equal to each other. We're getting to that in quite a little while. So to find out where they are equal, you're going to have to take your graph and estimate. The points where they are equal is there. And what's that value there? I'll have to check your graph. It should be more like 30-35-ish to that side, but check your graph. What do you see there? So whatever you write there, I'm going to accept as long as it's less than 45. Now 44,9, I'm also going to say, nah. Okay? Less than, mine even looks more like halfway maybe. 30, 29, whatever goes. Are you with me? So I'm going to say x is equal to, I said 40. Mama's not going to cry about that, 40. But you have to say at A. I want to read off where you did it. So you're going to call this point A. That's not A. This, where you read it off on the axis, that's where you put your A. And that wasn't the only place that they were equal. They were also equal there. And that was something I know is exactly at 270. And I'm still going to say there is my B point. So at A, or x is equal to 270 at B. Guys, techniques for reading off of graphs. You've got to show me where you read it off. Sometimes I'll give you the x value, especially in the algebra. If I give you the x value, how do you find the y? So you go up, dot, 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 and then you say, there's your C or your whatever you want to call it, where you read it off. That's not where you read it off. Okay. Then we go to number 8 that says, where is the, and this is where the color comes in nicely, where is the orange F graph smaller than the yellow graph? Because if you've got it in color, it helps. So we're going to check out where's the orange smaller than the yellow. Orange smaller than the yellow. We start from the left-hand side. Is the orange smaller than the yellow? Yes. Up to where? Yes. Whatever your A is. So if you say 27, you're going to now again say 27. Are you with me?
Yes.
It's changing it all the time. So from negative 90, this is the way that we write it again, up to, I said 40. Whatever you said, right? Include, exclude. Normally when that says include, I want to include both of them, right? Now think about it. On that point, is the orange smaller than the yellow? Yes. Definitely. And on that point, is the orange smaller than the yellow? No, but can it be equal? Yes, they said it can be equal. So both of them are answers that I would like to include. Is that the only place that orange is less than the yellow? Yes. Okay, but also the question said equal. So it's not underneath, but there's another point of equalness. Just exactly x equal to 270. Can you imagine that a lot of kids are going to miss that one? Because you have to check not only where the one is below, but also where they are equal to each other. Right. Then we get to our difficult question, usually that kids have a problem with. What's the story? If I want to know where they multiplied, then the answer must be
0. But less than.
Less than, smaller than. Negative is the word I'm looking for. Because negative means I'm telling you that a plus times a minus will give me a minus. And this is what I'm looking for. So if this was a plus, I wanted what? 2 pluses or 2 minuses. What does it mean? If I want 1 plus and 1 minus, I want 1 above the x-axis, that's where it's positive, and 1 below the x-axis, that's where it's negative. So now all of our papers look like this with a smaller than. So you've got to realize we can also ask bigger than. So if I'm asking for smaller than, I'm looking for 1 above and 1 below. And which one? Any one of the two. Above, any one of the two below. But again, we're going to check. Is the one from the left-hand side, checking it out, is the one above and the one below?
Yes.
Definitely. Up to where? No. Yes, I hear it? 0.
Oh.
Then the orange one is also above. So only up to 0 is the one below and the one above. So from minus 90 up to 0, guys. The one is on the top of the x-axis and the one at the bottom, meaning it's one is positive, one is negative. Include, exclude. Now again, with the include, exclude, if all else fails, just at least try to include all of it. Is it true though for minus 90 that the one is positive and the one is negative?
Yes.
Yep. And at 0, yes. The one is actually 0. The other one, I don't know what that is. I should have actually put it in there. Let's just go back and get myself the marks that I deserve. I said to you when you're sketching it, you should be showing me all of the axes intercepts. You should be telling me what that y-intercept is how. For the yellow graph, we're going to substitute x with 0. And please, what is the answer of cos 0 plus 45? Cos 45 is 0, comma 0.7 again. Do you see it being symmetrical over here again? Okay, but it's not necessarily always like that. Just rectifying myself. So now I can say, okay, you've done all the x-intercepts, all the y-intercepts, all the turning points. I'm happy with you. Okay, sorry, back on my track. So for 9, minus 90, is that included? Yep. And for 0 also, because one of them is 0, times the other one's value will still say 0, and the answer can be either 0 or negative. Let's carry on. Does it happen again that the one is above and the one is below?
Yes.
After 0, they're both at the top, right?
Yes.
Up to where?
45.
45, not A. They're both above until there. Then the one is below and the one is above. From where? From 45 up to where is the one above and the one below? Excellent. Because then they're again both above. So from 45 up to 225. In general, guys, if you don't know what you're doing, just at least say that says include, so include, and you correct 90% of the time. What it actually means is, on that point, this y is 0 times with anything else. I'm going to say the answer is 0 and the same thing over there. So it is included. Don't I have to include something else? No, it's all about one above and one below. No. All right. So for our last question, the easier one of the lot, I think, and whether it's F or G or whichever graph, I'm asking you where the graph is negative. Where's the y value at the bottom? Could I ask you for bigger than? That would be an alternative. So then you just check where the graph is above the x-axis, where it's positive. So the G graph, the yellow graph, must be below the x-axis. From where to where? 45 up to 225. Include exclude. Why exclude? The sum says less than. So it must only be less than, not equal to 0. And if they said equal, then you would have included both of them.